We'll start with another chapter of derivatives which is called as higher order derivatives. This is called as higher order derivatives. Right? Let's see the sum, guys. Now, in higher order derivatives, basically you have to differentiate multiple number of times. What is higher order derivatives? Higher order derivatives is where you have to differentiate multiple number of times. Let's see the sum, guys. Y is equal to e raised to m cos inverse of x. You have to prove that 1 minus x square d square y by dx square minus x dy by dx minus m square y is 0. Right? Let's see this. Now, the given sum is y is equal to e raised to m cos inverse of x. Differentiate with respect to x. If I differentiate with respect to x, this will be d by dx of y is d by dx of e raised to m cos inverse of x, right? So this is going to be dy by dx. D by dx of e raised to u is e raised to u d by dx of u, right? Now, e raised to m cos inverse of x is y. I can substitute e raised to m cos inverse of x as y. So I'll get dy by dx is equal to y. I can take m constant outside. D by dx of cos inverse of x is minus 1 upon square root of 1 minus x square. Now I could take the 1 minus x square on the other side. 1 minus x square dy by dx is equal to my. In order to get, look at my answer. In my answer there is no square root sign. Since there is no square root sign here, I don't need a square root sign. So I need to get rid of the square root sign. How do I get rid of the square root sign? Simple, by squaring both sides. If I square both sides, I will get this. This is nothing but 1 minus x square dy by dx the whole square is equal to m square y square. Once you have this, since I want d square y, I'm going to differentiate this again. Differentiate with respect to x. So you will get d by dx of 1 minus x square dy by dx the whole square is equal to d by dx of m square y square. Right? Here you will be using the uv formula. This is v derivative of u plus u derivative of v, right? Now here m square can be taken common. D by dx of y square, composite formula 2y dy by dx, right? Let's move on ahead, guys. Let's see this. Dy by dx the whole square 0. D by dx of x square is 2x plus 1 minus x square. Here I can use the formula d by dx of u raised to n. D by dx of u raised to n is n u n minus 1 d by dx of u is equal to m square 2y dy by dx, right? Now minus 2x dy by dx the whole square plus 1 minus x square into 2 dy by dx. Now guys, look at this. D into d is d square. So I can write d square y. Dx into dx should be dx the whole square. But in derivatives, as per convention, we do not put the bracket for dx the whole square. So we will write dx square as this way. This means dx the whole square, we are not drawing the bracket, that is the convention, okay, is equal to m squared 2y dy by dx. Now on the left hand side I can take 2 common, dy by dx common. So in that case you will get minus x dy by dx plus 1 minus x square d square y by dx square is equal to m squared 2y dy by dx. 2 and 2 gets cancelled, dy by dx and dy by dx gets cancelled, minus x dy by dx plus 1 minus x square d square y by dx square is m square y. Rearrange the terms, guys. If I rearrange the terms, I'll get 1 minus x square d square y by dx square minus x dy by dx minus m square y is equal to 0. Now if I were to look at the answer, this is exactly what I have to prove. Can we see the answer? That was exactly what we have to prove. So in higher order derivatives, basically you differentiate 2 types. Fine, do we get this? Let's move on to the next one, guys. Y is equal to sine inverse of x the whole square. You have to prove that 1 minus x square y to the base 2 minus x y to the base 1 is 2. Right? Let us see how do we do this. Now first of all, before we start the sum, let us look at one concept, guys. We will see this concept. dy by dx is also written by some authors and in some books as y to the base 1. Similarly, d square y by dx square is also written as y to the base 2. So there is no need to get confused as to what is y to the base 1 and y to the base 2. dy by dx is y to the base 1. d square y by dx square is y to the base 2. Now that our concept is clear, let us start with the sum, guys. Y is equal to sine inverse of x the whole square. Differentiate with respect to x. So you will get d by dx of y is d by dx of sine inverse of x the whole square. You will use the formula u raised to n. This is n u n minus 1 d by dx of u. Right? Now this can be written as 2 sine inverse of x. dy dx of sine inverse of x is 1 upon square root of 1 minus x square. Now can you just look at the question, please? Now the question says that y is equal to sine inverse of x the whole square. If I take square root on both the sides, I'll get square root of y is sine inverse of x. That means sine inverse of x can be substituted as square root of y upon square root of 1 minus x square. So that's what my dy by dx is. Take square root of 1 minus x square on the other side. So square root of 1 minus x dy by dx is 2 square root of y. Squaring both sides. If I square both sides, I'll get 1 minus x square dy by dx the whole square is equal to 4y. I've squared this term, I've squared this term, I've squared this term and this. Now differentiate this again. Differentiate with respect to x. So you will get d by dx of 1 minus x square dy by dx the whole square is equal to d by dx of 4y. Right? Now here you will use the uv formula. uv formula, v derivative of u plus u derivative of v is equal to 4 dy by dx. dy by dx the whole square into dy dx of 1 is 0, dy dx of x square is 2x plus 1 minus x square, dy dx of u raised to n u n minus 1 dy dx of u is equal to 4 dy by dx, right, minus 2x dy by dx the whole square plus 1 minus x square 2 dy by dx. As I explained to you in the previous sum, this is going to be d into d, that is d square y upon dx square is 4 dy by dx, right? Now here I could take 2 common, dy by dx common, in which case you will have minus x remaining from here, dy by dx remaining from here, 1 minus x square d square y by dx square is equal to 4 dy by dx. 2 1s are, 2 2s are, dy by dx and dy by dx gets cancelled, so you will get 1 minus x square d square y by dx square minus x dy by dx. Now this plus 2, when I bring it on the other side, will become minus 2 is 0. Now right in the beginning I explained this concept to you that d square y by dx square is nothing but y to the base 2, y to the base 1 minus 2 is 0, and I presume that's exactly what you had to do. This is exactly what you have to do. Fine, do we get this thing clear? Let's move on to the next one, guys. Y is equal to log of x. You have to prove that x y to the base 2 plus y to the base 1 plus x y to the base 1 the whole square is 0. Let us see the sum, guys. Now I can say straight away differentiate with respect to x. So you will get d by dx of y is d by dx of log x, right? Now I'll say dy by dx log u 1 upon u d by dx of u, right people? Now I can say that dy by dx is 1 upon log x into 1 upon x, right? Now I could take that x on the other side, so I'll get x dy by dx is nothing but log x the whole raised to minus 1. I took the x on the other side and log x in the numerator, that becomes log x raised to minus 1. Now differentiate with respect to x, so you will get d by dx of x dy by dx is equal to d by dx of log x raised to minus 1. Here I can use the uv formula, v derivative of u plus u, I'll just redo this as v derivative of u plus u derivative of v. Now this is d by dx of u raised to n, this is n u n minus 1 d by dx of u, right? Now this is going to be dy by dx plus x d square y by dx square is minus 1. Log x raised to minus 2, I can take that in the denominator. So this will be log x the whole square. D by dx of log x is 1 upon x, right? Now I can say that dy by dx plus x d square y by dx square is equal to 1 upon log x the whole square into minus 1 upon x. Now, can you see this step, guys? This step implies that x dy by dx is nothing but 1 upon log x. That's the meaning of this step. This step says that x dy by dx is 1 upon log x. That means 1 upon log x, the whole square will be the square of this term. 1 upon log x, the whole square will be x plus dy by dx, the whole square. That is exactly what I'm going to do. I'm going to substitute. So you will get dy by dx plus x d square y by dx square is equal to x dy by dx, the whole square, into minus 1 upon x. What did I do here, people? I substituted 1 upon log x the whole square as x dy by dx the whole square. So you will get dy by dx plus x d square y by dx square is equal to x square dy by dx the whole square into minus 1 upon x. X and square gets cancelled. Substitute. This is y to the base 1 plus x y to the base 2 is x y to the base 1 the whole square. Rearrange x y to the base 2 plus, here I forgot to write the minus sign, plus y to the base 1 plus x y to the base 1 the whole square is 0. The minus sign came in here, when it goes on the other side becomes plus, and that's exactly what you are doing. Fine, do we get this thing clear? Let's move on to the next sum, people. Y is equal to x plus root of x square plus 1 the whole raised to m. Prove that x square plus 1 d square y by dx square plus x dy by dx minus n square y is 0. Let us see how do we do this sum. Y is equal to x plus square root of x square plus 1 the whole raised to m. Let's start. I can straight away differentiate this. Differentiate with respect to x. So I'll get d by dx of y is d by dx of x plus square root of x square plus 1 the whole raised to m. Now this is u raised to n. So n u n minus 1 d by dx of u. Right? Do we get this thing clear? Now, this can be written as m. Now, law of indices. If I use law of indices says that a raised to m minus n is a raised to m upon a raised to n. If I use this law of indices here, I will get this as x plus square root of x square plus 1 raised to m upon x plus square root of x square plus 1 raised to 1. I'm using law of indices here. Moreover, here d by dx of x is 1 plus d by dx of root u is 1 upon 2 root u d by dx of u. Right? Now this can be written as m x plus square root of x square plus 1 the whole raised to m upon x plus square root of x square plus 1 1 plus 1 upon 2 square root of x square plus 1 into d by dx of x square is 2x and d by dx of 1 is 0. Now cancel the 2 and 2. This is m x plus square root of x square plus 1 the whole raised to m. From the question x plus square root of x square plus 1 the whole raised to m from the question can be substituted as y. So I'll get this as my upon x plus square root of x square plus 1 is square root of x square plus 1 plus x. What did I do here, people? I took LCM. Square root of x square plus 1, x plus square root of x square plus 1, x plus square root of x square plus 1, my upon square root of x square plus 1, cross multiply. So you will get square root of x square plus 1 dy by dx is equal to my. To get rid of the square root sign, square both sides. If I square both sides, I'll get x square plus 1 dy by dx the whole square is m square y square. Right? Now, this can be written as differentiate with respect to x dy by dx of x square plus 1 dy by dx the whole square is nothing but d by dx of m square y square. I'm just multiplying both sides by d by dx. uv formula, this is v derivative of u plus u derivative of v is equal to m square. d by dx of x y square is nothing but 2y dy by dx. Right? Now this can be written as dy by dx the whole square into d by dx of x square is 2x. 1 is 0, I need not write that, plus x square plus 1 d by dx of dy by dx the whole square u raised to n u n minus 1 d by dx of u is equal to 2m square y dy by dx. Here I could take 2 common, dy by dx common. So if I take 2 common, dy by dx common, you will have x dy by dx remaining from here plus x square plus 1. 2 dy by dx is gone, d into d is d square y upon dx square is equal to 2m square y dy by dx. 2 and 2 is gone, dy by dx and dy by dx is gone. So in this case you will get x dy by dx plus x square plus 1 d square y by dx square is m square y. Take the m square y on the other side and rearrange the terms. So you will get x square plus 1 d square y by dx square plus x dy by dx minus m square y is 0, and that's exactly what I did. That was the sum that had to be. Right? Let's move on to the next sum, guys. ax square plus 2hxy plus by square is 0. You have to prove that d square y by dx square is 0. Right? Now let's see this very interesting sum. ax square plus 2hxy plus by square is 0. Now here I can split this up as ax square plus hxy plus hxy. 2hxy, I am splitting it as hxy plus hxy plus by square is 0. Now between the first and the second term I can take x common. So I will have ax plus hy between the second term and the between the third term and the fourth term, I can take y common. So in which case I will get hx plus dy is 0. Take that on the other side, so I will get x ax plus hy is equal to minus y hx plus by. I could cross multiply, in which case I will get x upon y. I am taking the minus sign also on this side, so minus x upon y is hx plus by upon ax plus hy. Call this as equation 1 and leave the sum here as it is. Let's start with the sum again. Ax square, the original question I am writing here, 2hxy plus by square is 0. Differentiate with respect to x. If I differentiate with respect to x, a is as it is. X square is 2x plus 2h xy. Y d by dx of x. Y d by dx of x plus x d by dx of y plus b. Y square is 2y dy by dx is 0. So I will get 2ax plus 2h y plus x dy by dx plus 2by dy by dx is 0. Let's open the bracket and simplify this, guys. So you will get 2ax plus 2hy plus 2hx dy by dx plus 2by dy by dx is 0. Since all the terms have 2, I can divide by 2. If I divide by 2, the 2 will get cancelled. Moreover, I am going to keep the dy by dx terms on one side and the non-dy by dx terms on the other side. So I am going to divide by 2. All the 2 goes. Now I am going to keep the dy by dx terms on one side. So hx plus by between the third and the fourth term, hx plus by dy by dx common is equal to minus ax minus hy. Right? Now, so therefore I could say that dy by dx minus sign common ax plus hy upon hx plus by. Right? Now, let's look at equation 1. Equation 1, from equation 1, I can say that minus x upon y is equal to hx plus by upon ax plus hy. Reciprocate this. If I reciprocate this, I'll get y upon x minus y upon x is equal to ax plus hy upon hx plus by. And that is exactly what was my value of dy by dx. So instead of writing ax plus hy upon hx plus by, I can, this minus sign as it is, I can write minus y upon x. Therefore, you will get dy by dx is equal to y upon x. Right? Let's continue with the sum up. I can say that I have got dy by dx is equal to y upon x from down. Differentiate this again. If I differentiate with respect to x, I will get d by dx of dy by dx is d by dx of y upon x. Now, this is going to be d square y upon dx square. Here you will use the u upon v formula. If I use the u upon v formula, this is v derivative of u minus u derivative of v upon v square, right? So you will get d square y upon dx square is x dy by dx minus y upon x square. But we have already found the value. Of dy by dx as y upon x. Hence, I can substitute the value of dy by dx as y upon x in which case I will get d square y upon dx square is equal to x. I am substituting the value as y upon x minus y upon x square. X and x gets cancelled, so you will get d square y upon dx square is y minus y upon x square. D square y upon dx square is 0. Y minus y is 0. Anything divided by 0 is 0, and that was exactly what I had to do. A very good sum, right? Let's move on to the next sum, guys. X is equal to 80 square, y is equal to 280. You have to prove that x, y to the base 2 plus a is 0. Let's see the sum, guys. X is equal to 80 square. Differentiate parametric with respect to t. So you will get d by dt of x is d by dt of 80 square. So you will get dx by dt is a as it is. T square is 2t. Let's call this as equation 1 and leave this here. Y is equal to 280. Differentiate with respect to t. So you will get d by dt of y is d by dt of 280. So you will get dy by dt is equal to 2a. Call this as equation 2. Now I can say that dy by dx is nothing but dy by dt upon dx by dt. Now dy by dt is 2a, dx by dt is 2at. 2a and 2a gets cancelled. Therefore I get dy by dx is equal to 1 upon t. Differentiate this again. Differentiate with respect to x. If I differentiate this again, I will get d by dx of dy by dx is d by dx of 1 upon t. This is nothing but d square y upon dx square. D by dt of 1 upon t is nothing but minus 1 upon t square. D by dt of minus 1 upon t square. This should be x. D by dx of 1 upon t is minus 1 upon t square. D by dx of t, we are differentiated with respect to x. Now this can be written as d square y upon dx square is minus 1 upon t square. Dx by or dt by dx from equation 1. From equation 1 we know that dx by dt is 280. That means dt by dx should be 1 upon 280. So dt by dx can be written as 1 upon 280. Now this is d square y upon dx square is t square 280. I am writing the two terms separately. The minus sign as it is in the numerator. I am multiplying by a, I am dividing by a. I am multiplying by a, I am dividing by a. Right? So you will get d square y upon dx square is minus a. Now if you look at the original question, 80 square is nothing but x and 280 is y. Look at this, guys. 80 square is nothing but x and 280 is nothing but y. So I can cross multiply, I will get x y. D square y by dx square can be written as y to the base 2 is equal to minus a. Take a on the other side, so I will get x y to the base 2 plus a is 0, and that is exactly what I had to prove. Right? Do we get this over here?